and this is our experiment, and it's the iodine clock reaction.
And before we start the iodine clock reaction, I'm going to tell you about some background. The iodine clock reaction was first founded by Hans Landau in 1886. The iodine clock reaction is when two chemicals are mixed together and form a reaction of shade, turn to a shade of garnet. If this happens, then that means the two chemicals are met as exact. If it can also result as a shade of brown, brown and black. If it turns out a shade of brown, then that means that a little bit too much starch was added to the solution. If it changes to black, that means way too much starch was added to the solution. So to test our hypothesis, we did some experiments and we changed the temperature. We increased the temperature and decreased the temperature on two experiments. We controlled the concentration, so we lessened the concentration of two experiments, and then for the last one, we added a catalyst.
The problem is that we were trying to ask ourselves is the environment reaction affecting the time that is taking place of the reaction is taking place?
Well, our hypothesis that our group came up with was that the environment did indeed affect the chemical reaction, and it affected the time it takes for the chemical reaction to take place. At this point, we would make a mixture, and we would give you an example, but we're out of the stuff that's needed. Yeah, I used that too quickly. I got a little happy. I got a little chemical happy. To test our hypothesis, we put it in a control environment and then 4 other environments. In the control environment, we had them at room temperature or 20 degrees Celsius. We had 100 milliliters of both solutions, and then no catalyst was added. We had one environment where it was heated, where we instead of having them at 20 degrees, we increased their temperature to 60 degrees. We had one where we cooled them down to 10 degrees Celsius. We had an environment where we added a catalyst, and we had one environment where we added 50% water to each solution. According to the table that we recorded, the control had an average of 35.33 seconds. The heated had an average of 9 seconds. The cool had an average of 38.66 seconds. And the catalyst had an average of 16 seconds. While the longest one, the less concentrated environment, had the longest average with 102 seconds.
For our materials list, we had 2 1,000 milliliter beakers, 2 500 milliliter beakers, 10 grams of sodium iodate that will once be left over, 15 grams of starch that will be left over, 25 grams of citric acid that will be left over, 5 grams of sodium sulfate, 1 gram of copper, and we use a thermometer, gate device, heat plate, balance, available tap water, spatula, stopwatch, safety goggles, safety gloves, paper, pencil, and calculator.
After testing all these environments, we came to the conclusion that anything that makes the molecules move faster gives them a better chance to hit each other and react, while anything that slows them down will cause the time to increase because they don't have as much chance to hit each other. And that's our experiment. I would have shown you guys, but we're out of it.
Any questions?